Alright guys, today we're going to talk about how you can write a polynomial function with the following zeros. Okay, so we've talked about this before, how to write a polynomial function when we're given the zeros. However, in this problem, we're dealing with complex zeros. Alright, in the other problem that we did, we were dealing with only real zeros. Okay, so we can see here that we have a square root of 2. And then we have this complex number here, 1 plus I, okay? And then we have negative 4. Well, in order to do this, remember that the zeros come from when you're factoring, right? So in order to get the polynomial function here, we need to put these back into factored form. But before we do that, we need to define all of the zeros here, because even though we have the square root of 2, 1 plus I and negative 4, there are actually more zeros here. You just didn't write it out. Okay, well, for example, we have a positive square root of 2. Well, we know that if we take the square root of anything, we'll always have plus or minus. So if we have the square root of 2, we must also have the negative square root of 2. All right, so that is going to be another 0. And then we have this complex number. Well, remember, we talked about how we can find the complex conjugate. And we're also going to have a negative I here, because remember, I is the square root of negative 1. And again, whenever you take the square root, you have plus or minus. So we will also have 1 minus I. Okay? And that is it. So these are all going to be our zeros here. So again, how this looks is you're saying x equals the square root of 2, right? X equals negative square root of 2, x equals 1 plus I, x equals 1 minus I, okay, and x equals negative 4. And we said that if we're trying to find the polynomial function, we have to put these back into factored form. Okay, so we're going in reverse now. Okay, before we're finding the zeros, now we're trying to find the function, so we go in reverse. So we put these back into factored form, and when we do that, we now get x minus the square root of 2, x plus the square root of 2, okay, this will be x minus, and I'm going to put this in parentheses, okay, that way there's no confusion with the signs. We'll have 1 plus I, okay, and right here, x minus, same thing, 1 minus I, okay, and now we have x plus 4. Okay, so what we need to do, we need to put these factors together and then we need to expand it out. Alright, so let's rewrite each one of these together and then we'll go ahead and expand it out. Alright guys, so I went ahead and wrote out our factors side by side. Notice how I kept the radicals together, I kept the complex numbers together. This will just be easier when we go ahead and expand this out. So what I'm going to do here, we'll break this up into 3 parts, okay? First we'll work on this part, then we'll work on our complex numbers, okay, and then we'll work on this last part here. So let's go ahead and do this. Well, you may be looking at this and you may notice that this is a difference of 2 squares, alright? So when we do this operation out, okay, we'll do FOIL here, we'll get x squared, and again, since it's a difference of 2 squares, we aren't going to write that middle term because they're simply going to cancel each other out. Alright, and then we have the negative square root of 2 times the square root of 2. Well, the radicals will naturally cancel itself out and we're left with just negative 2 here. Okay. Alright, now let's look at this part here. So what I would do, okay, we want to distribute this negative inside the parentheses. So let's see what happens when we do that. When we rewrite this, we will get, I'm going to write it right here, x minus 1 plus I, okay, and we get x minus 1 minus I. Okay, and then we're going to simply just go ahead and do these operations out. So each term here, we have to go ahead and distribute. So starting here, x times x, you will get x squared. X times negative 1, that's negative x. X times negative I, that's negative ix. Okay, moving on. Negative 1 times x, that's negative x. Negative 1 times a negative 1, that's plus 1. Negative 1 times a negative I, that's going to be plus I. Moving on, I times x, that's positive ix. Okay. I times a negative 1, that's going to be negative I. And then I times a negative I squared will be negative, I times a negative I will be negative I squared, Okay. And we know that I squared is really negative 1, so if we replace this with a negative 1, this whole thing becomes plus 1, okay? So plus 1. Now at this point, let's go ahead and cancel out any terms. Okay, so we have, let's see here, an x squared, so we're going to go ahead and write x squared. So we're done with that. Then we have a negative x and a negative x. That makes negative 2x. And notice here, negative ix and a positive ix, well, those will simply cancel each other out. I have an I and a negative I, same thing, they will cancel each other out. And then I have a 2 and a positive 2, so this will be plus 2. Alright? Okay, so let's rewrite what we have so far. So I'm going to erase this work. I'll write this right beside it. We have x squared minus 2x plus 2. Okay. Then we have x plus 4. Alright, so this is a long one. So remember, our goal here is to expand this out. So at this point, what we can do, it's really up to you how you go about doing it, but I'm going to go ahead, right, and I'm going to go ahead and multiply each one of these terms by this guy right here. So we're going to look at this part right here. So let's go ahead and do that. You get x times x squared, that's going to be x cubed. Then we have x times a negative 2x, that's going to be negative 2x squared. Okay. Then we have x times 2, that will be plus 2x. Okay, now moving on. So we plus 4x squared minus 8x. Okay, and then plus 8. So you want to do the same thing here, combine any like terms, cancel any terms that may cancel out. So I'm only having x cubed here, so x cubed, we're done with that. Negative 2x squared and a plus 4x squared, that would be plus 2x squared, so we're done with that. Then we have a 2x and a negative 8x, that will make it negative 6x, and then just plus 8. Alright, almost done here. So we're going to erase this and write our new expanded polynomial that we got. So now we have x cubed plus 2x squared minus 6x plus 8. Alright, we are almost done here. Same thing, all we have to do now is go ahead and multiply all these out. So x squared times an x cubed will all be x to the fifth. X squared times a 2x squared, so now we get plus 2x to the fourth. Right, x squared times a negative 6x, that will be negative 6x cubed, okay? X squared times an 8 plus 8x squared. Alright? Moving on, negative 2 times x cubed, negative 2x cubed. This will be negative 4x squared. Okay, that will be positive 12x. And this will be negative 16. Alright. Almost done. Okay, let's just combine our like terms now. So we have x to the fifth. Well, that's all we have, so we'll just write it again. X to the fifth. And actually, let's do this one in a different color. This is going to be our final answer. So we'll have x to the fifth. Okay, we're done. Then we look here to the fourth power, so that's all we have, plus 2x to the fourth power. Okay, gone. Oh, now we have a negative 6x cubed and a negative 2x cubed. That makes negative 8x cubed. Gone, gone. Positive 8x squared, negative 4x squared, plus 4x squared. Okay, and then just plus 12x and minus 16. So this is our final answer. Okay, so that was a long one. All right, got to be really careful with your signs, because it's easy to make a mistake. But that is how you go about writing a polynomial function when they give you the zeros. And in this case, they gave us complex zeros and they also give us radicals. So it's important that we include those other zeros, even though they may not give them to you outright. Okay, so your final answer is on the bottom.